Hey everyone, and welcome. Today, we are going to write a complete working Arduino program right from scratch. Seriously, by the time we're done here, you'll have taken lines of code and turned them into a real, physical blinking light. It's going to be fun.
So, here's our game plan. We'll start with our main goal, get to know the three most important commands we'll need, then we'll actually write the blink code. After that, we'll see it in action, and we'll wrap up with a little challenge for you to test what you've learned.
All right, let's just dive right in. You know, in programming, the very first thing anyone learns is how to make the computer say hello world. Well, for hardware, the equivalent is making something happen in the physical world. And our hello world is going to be making that little LED that's built right onto the Arduino board blink. It's a simple goal, but it's super satisfying. Now, the key thing to know is that this tiny light is already wired up for us to digital pin number 13. That's the pin we're going to take control of.
Okay, so before we can start writing code, we need to get familiar with our tools. There are three fundamental commands that are going to be the building blocks for our entire program. Let's get to know them. First up is a command called pinMode. Its job is pretty straightforward. It tells a specific pin on the Arduino what its role is. Is it going to be an input waiting to receive a signal, or is it going to be an output ready to send a signal out? For what we're doing, this is the exact line we'll use. We're telling pin 13 to be an output. Why? Because we're sending a signal out from the Arduino to the LED. And hey, pay close attention here. Notice the capital M in pinMode, and that output is in all caps. Programming can be really picky about this stuff, so case sensitivity is key. Our second tool is digitalWrite. So once we've told a pen it's an output, this is the command we use to actually send electricity through it. You can think of it as our digital on and off switch. So what does this on and off switch do? Well, digitalWrite has two settings. When we send a high signal, the Arduino sends out 5 volts of power. That's the on state. And when we send a low signal, it sends 0 volts. That's our off state. It's really that simple. So putting it all together, to turn our LED on, we'll use this command to digitalWrite a high signal to our pin, which is pin 13. And just like before, watch that syntax. The capital W in digitalWrite is a must. And our third and final essential command is delay function. This one does exactly what it sounds like. It tells the Arduino to just pause, stop everything, do nothing, and just wait for a specific amount of time. It's how we'll control the rhythm of our blink. Now, here's a really important little detail about how the Arduino thinks about time. It doesn't use seconds, it uses milliseconds. So if we want the program to pause for 1 full second, we actually need to tell it to delay for 1,000 milliseconds. All right, we've got our 3 essential tools: pinMode, digitalWrite, and delay. Now it's time for the fun part. Let's see how we assemble these into a complete working program. So every single Arduino program has 2 main parts. The first is void setup. This section runs only one time, right when you power up the board. It's for all the prep work. The second part is void loop. And just like its name suggests, this part runs over and over and over again forever. This is where the main action happens. So think about it. We only need to tell the Arduino that pin 13 is an output one time, right? That makes it perfect for the setup function. We set it up once at the beginning, and then we never have to worry about it again. Now, for the logic that goes inside our repeating loop function, it's really just a simple 4-step dance. We're going to turn the LED on, wait a second, turn the LED off, and wait another second. Then, because it's in the loop, it'll just repeat that forever. And here is what that logic looks like as actual code. Inside our void loop, we use digitalWrite to set pin 13 to high. Then we delay for 1,000 milliseconds. Then we digitalWrite pin 13 to low and delay again. As soon as that last delay is finished, the program jumps right back to the top of the loop and does it all over again, giving us that perfect, steady blink. The code is written. Now for what is, honestly, the most satisfying part of this whole process: sending our instructions to the Arduino board and seeing it come to life. So you just connect your board to your computer, hit that upload button in the software, and in just a few seconds, you'll see it. That little LED on the board, usually labeled with an L, will start to blink. On for a second, off for a second. That's your code, running in the real world. Okay, you've seen how it all fits together. So to wrap things up, let's do a quick little challenge. It's time to put your brand new knowledge to the test. Take a good look at these 2 programs. At first glance, they look almost identical, right? But one of them has a small logical mistake that will stop it from blinking correctly. Based on what we've just gone over, can you spot the error?
So, what's your verdict? Is program A the right one, or is it program B? And here's the real test. Can you explain exactly what's wrong with the incorrect program? Think about the flow of the code. Let us know what you think down in the comments below.